Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of exponential functions, specifically how we can graph them if simply given the equation, and we will do it in 5 minutes or less. So when we're talking about exponential functions, we need to know what standard form looks like. Y equals a times b to the x power. And you can actually tell an awful lot from this function. Now, in a pinch, you can always pull out your graphing calculator and plug it in and just see what the graph looks like. But a lot of times you can tell what it's going to be just from the equation. So let's start with this a term, right? Because typically your y and your x are still just going to remain y and x as your independent and your dependent variables. But this a term is going to be very important because it acts as multiple things depending on the context. So if it's a word problem, right, it's going to possibly be your principal. So when we're dealing with compound interest or investing money, it's the amount of money you initially deposited in the account. It also can just simply be your starting amount or your initial amount. When we're dealing with bacterial growth, we're dealing with some item or something growing over time or decreasing over time, there's always a starting amount. That's what a is. For our purposes, since we're graphing it, we need to think of it as our y-intercept, and that's going to be very important. So the y-intercept, how do we know it's the y-intercept? Well, that's where the graph crosses the y-axis when x equals 0. Now, take a look at this. What if I were to make x equals 0? Well, I'm just going to make it b to the 0 then, right? What happens when we make any number to the 0 power? Right, it just turns into 1. So it's just a times 1, which is just a, right? So when x equals 0, y equals a. So that's how we know it is our y-intercept. So that's an important term here. And this b is going to be your rate. Now, it's going to either increase or it's going to decrease. So we've got a growth rate if it is greater than 1, which means if you were to graph it, right, it's going to kind of go up like this. And then you have a decay rate if it's less than 1. So look for decimals, look for fractions. And it's going to start high and then kind of move down like that. So let's take a look at two sample ones right here. We could say y equals, I'm just going to pick an a of 2, 0.1 to the x power. Okay, so what would that look like? Well, if I were to graph that right here, we know that if that's 2 right there, we know that's our y-intercept because that's our a right there. We know that this is going to be a decay factor because it is less than 1. So it's going to start over here in quadrant 2, and it's going to kind of slide down there, and then it's going to always continually get closer to that x-axis but never quite reach it because that is your line of asymptote right there. So your asymptote is always going to be the x-axis unless you do like a +7 or a -8 or something like that to shift the whole thing up or down. The asymptote is going to be your x-axis. Well, we can do another one right here. Right? We could do y equals 2. Let's make it a growth factor, 10. Right? So I'm going to make it 100 times bigger, that b right there, to the x. Notice I kept the exact same a, which means it's still going to have that y-intercept of 2, but now what we're going to do, our asymptote is going to kind of be over here, and it's going to kind of slide up. It's going to kind of move like that. So let's see if we're correct. So we see this blue one here is increasing. It's got a growth rate, so that's going to be this y equals 2 times 10 to the x power. You see this red one is decreasing. It has a decay rate, so that's going to be the y equals 2 times 1/10 to the x power. Both with a y-intercept of 2.